Okay, so welcome to the third lab of this session. And today we are going to be looking at databases. All right, so every application you build would definitely need to use a database. You need to store data somehow. And Google, or Android, if I should say, makes it easy for us. They created this wrapper around SQLite called Room, and it makes working with databases much easier. And so previously you would have to use SQLite, but now Room has become the de facto way of storing data locally. So today we are going to see how we can store data in our database, and we'll be making changes to our application to do that. So we currently already have an idea about Android Studio, and we did some UI prototyping over the past few days. And then today we'll be looking at database. Next week, we'll look at reminders and notifications. Then we'll go into geolocation stuff. All right, so what are we going to be doing today? Today, we are going to be displaying a list of payments. Actually, the image already shows a list of payments there, but that is not what we are going to. This we had coded last week, just to demonstrate how the lazy column works. But today we are going to be retrieving data from the database and displaying it here based on the category that is selected at the top. And also we are going to be saving payments into a Room database. Outside of this lab, I would want you to do some experiments for me. Okay, so I would want you to test this out, experiment with login. Currently, we only click on a button and then it goes to the next screen. But I would want you to experiment with the knowledge that you're going to gain from here to experiment authentication using a username and password. So you're technically going to be saving a username and password to the database. And when you come into login, you would have to validate or authenticate to the user. So if the user doesn't provide, or if you do not provide the right password or username, then you are not able to log in to see the screen. Next would be to validate your payment inputs. What we'll be working with today, we wouldn't be dealing with edit validation. So whatever text is entered, we do not check whether it matches an appropriate structure or not. But I would want you to try that out as well. And I will be super glad if you could send me a video recording. I will show you how you can record your mobile screen. And if you could send me a video recording of what you do, and I'll just take a look. All right. Thank you to all those who have reached out, who are facing issues and reached out to ask questions. Thank you for doing that. It is very important that you reach out as early as possible. And I really appreciate the fact that you tried stuff and you stated in your emails the things that you did that didn't work, and that was a good one. So please reach out anytime, send an email. If we are unable to resolve it through emails, we can book a session and have a one-on-one, so I can take a look at your screen at least and be able to provide some input. All right, so lists are a very important part of every modern application today. And you see lists in almost all the apps you do. The first one is your mail, your email apps. When you open it, you see a list of emails. When you open your social media, everything you see is technically a list. So the posts that your people you follow on Twitter are making appears in a list. Your Facebook feeds appear in a list, your WhatsApp messages, even your ordinary phone messages appear in a list. So these are just the 2 examples of lists, and you can see this whole thing is repetitive. So you see an icon to the left, and then there is a title, and then after the title is a username, then a time, and then there is a subtitle, and then a link. So you see the same thing repeat over and over and over. Okay, with this one, we see an additional image, but the other ones do not have an image. So these things repeat over and over and over, and it's just going to be the same thing that shows the whole time. On the right-hand side, we see the same thing. We see an image with a title, and then a sub title, another sub, and then you see a share and a learn more buttons there. And you can see a shape that makes this a card. So this is a list of cards, for instance, that has been displayed. All right, so lists are super important in every modern day app, and we have already tried it, and we are going to see how we can connect that to our database. All right, so this is just a link to compose lists once again, just for you to take a look and refresh your memories. But today, this is what we are going to be dealing with, the Room database. I provided a few links to the Google Developer website, and this is a Medium post that I saw appears very simple and easy to read, so I thought I'd share that as well. Okay, so this is our application down here. I took this picture from the Google website, from this first link. All right, so this is the rest of our application. And here sits our database. To access our database, we need something we call a data access object. So we are going to create a data access object, and only the data access object has access to the database. We don't. You cannot directly talk to the database. You need to go through this data access object. And this data access object saves entities into the database and retrieves entities back to your app. So your app makes use of this, but it's this data access object that does the communication between the database and the rest of your application. Now, a lot of layers have been removed from here. We do not use the data access object directly in the code. We would need to talk to something else, and that something else would be interacting with our application. All right, so I'm going to be showing this in code a bit later. So just have this picture in mind that we have our database sitting somewhere, we have our application sitting somewhere, and we need to communicate with our database, and we need this data access object to do that. Okay, so Room provides something we call object relational mapping, and it is technically mapping objects to database tables. All right, so remember we created this data class called payment previously, and this payment is the class that stores data for the payments screen that we do. So we create a payment, and it is this object that that contains that data. Okay, now to convert that class into a relation or a table in the database, we need to provide this annotation called entity, and then you need to provide a table name. Oftentimes we make the table names plural. So it's going to be the name of the class, of course, but you make it plural and small letters, all right? And then we made the ID, it's actually supposed to be val, not var, all right? Everything's supposed to be val. We make the ID the primary key, and we are saying it should auto-generate the ID. So whenever we create a payment, we are not going to supply an ID. The Room is going to generate that ID for us. And to make the other ones fields, we need to use this annotation at column info. and then we have to provide a name for that field. And that field, by field, excuse me, I didn't do a lot of updates in this thing. This is not supposed to be name, it's supposed to be title. Hold on. Let me just make this change right here and now. So we do not confuse those who would watch the video later. You got title, category, date, title, category. Let me just change this, ID, date, amount. Okay. All right. So to make this a column in the database, we need to annotate it with column info and then provide a name for that column in the database. So this represents the database table. So we have our ID, and this is the title, category ID, date, and amount. All right, so the names we are seeing here are the ones that we put in the column info. And then we have our variables that we had previously defined for the payment class. So we'll see how we are going to do this. And so Room is going to take this, and Room is going to convert this object that we have here, this class, into an entity or a database table in our database. So we do not handle that at all. Room handles it for us. All right. And to use Room, we need to include dependencies, of course, and we would be doing that, and I'll be showing that. But one important thing to note is the use of this capped. All right, it is super important to use capped, otherwise Room is not going to work, and I'll be showing that in the code as well. Okay, so here is our goal for today. We are going to be listing payments here, and we'll be saving payments into our Room database, and then your lab session is here for you as well to try out. Okay, this is it. I would want to show you what we'll be doing. Just a moment. I need to get this off. Okay. I believe you can see my screen, the Android app at least. So this we had created previously, we had data all the way here, but you can see now that they are all empty, except when it comes to investments, because yesterday I added a payment for books that I bought, and I think that books qualify as an investment. This is my personal opinion. Books qualify as an investment because I'm investing into my life. I'm going to read the books, and the books are going to give me some knowledge that I can apply to something. If books do not qualify as an investment, you can always create a new category and add books. So we click any other thing, and nope, I do not have any other payments made. All right, so let's create one payment. Also note that I made a slight change here. We had a date and we had something else. I removed the date because I understand that one of your tasks is working with dates. So I don't want to do that for you. So I took it out so you could experiment working with dates. All right, so I'm going to create a payment for food, and I'm going to say, lunch with Aku. So I had lunch with Aku, and I'm going to, so this list here from the categories, you can see is the same as the categories. I'm loading this from the database and displaying it in in the drop-down menu. All right, so I'm going to select food. And how much did it cost me? It cost me 10 euros. And then I'm going to save. And immediately it is saved and it displays here. And I told you I took off the date, but over here you can see the date. That is because while making the payment, I actually I use today's date. But you would have to provide a date field and do some implementations with the dates because we want to see that. All right, so here I just had lunch with Aku and say, dinner with Jose, and I'm going to set that to food as well. Dinner should be much more expensive. It's 35.5 euros. And I click on save, and dinner with Jose comes again under food. So we click on health, nothing, nothing, nothing. Investment shows nothing. Coffee has nothing either. And then we click on food, and the two payments that I just made are saved there. All right, so this is what we are going to be doing today. We'll try as much as possible to get to this point. I must state that I would, if we are not able to do everything, I would create some additional videos and upload that and share that with you as well. Okay, so enough of me talking. Let's get into writing some code. Any questions? Any questions so far? All right. So where do we begin? This is our payments. We're going to change this, and we will be using long. Payment category, we'll be using the ID instead. Yeah. Will be when we save a payment, we'll be providing the ID of the category that the payment belongs to, and persisting that instead of persisting the payment object, the category object itself, because Room has some limitations with regards to that. On the back end, it is very easy to actually even save the object in there, but on Room, which happens to run on the client side, processing issues prevents them from accepting that. Okay, so let us begin by creating our database. So where do we create our database? Our database falls within data, all right? So we are going to create a new package. It's not going to go into entities, it's going to go into data, and we can call it DB, but I prefer to call it Room. Okay. Now inside Room, we would have to create a class called mobile computing database. I hope that is the name of our project. Yes. Okay. So, yeah, we added to Git. All right. So what goes in here? This will be an abstract class. With abstract classes, we do not I would want to say that with the database, we would be using almost we'll be using abstract for everything. I think everything is going to be abstract, but we need to extend the room database, which does not exist. Okay, so if something does not exist and we need it, what do? We need to add a dependency for it. So I come in here and I need to add my room dependency. And I'm just going to copy it from what I have here. Okay, so I'm going to be using room KTX, and then I need this capt, this room compiler that is available with capt. But one thing that we need to do is this plugin. We need to go into the plugin and we need to include Kotlin capt. This is needed for room to work. This dependency, you can find it on the Google website. Just Google room room database. It's going to provide a list of documentations, Google, and you always find this there. But this code is actually going to be available, so you can see. You can also copy this from GitHub. You should have a link to the GitHub repo, at least from the previous exercises. All right, so we need this Kotlin add to work, and we are going to sync. So when we sync, and let me just close everything else. Okay. Okay, now it's here. All right, so now that we have imported room database, we can extend the room database. But what actually makes this database the database? We call this the room database for this app. It needs to take an annotation that it is a database. And then we need to supply all the entities that are going to be in this particular database as an array of entities. And then we need to provide the version of the database, and then export schema false. We are not going to be exporting the schema of the application of the database. We can set that to true though. All right, so this is how we create a database. We are not done yet, but this is just the structure. Now, how do we communicate with the database? We communicate with this database through data access objects. And so I'm going to create the first one, abstract fun, and it's going to be category DAO, data access object. And I'm saying that it's going to be of type category DAO. Now that belongs to definitely the category class. All right. So I'm going to import my class. Yeah. So now we need to create this category DAO. All right. So it comes also into the room and Kotlin class. And we are going to call this category. It's an abstract class. So, and how do we know this is a data as a subject? room allows us to import an annotation. So we place that annotation on our data access objects, and then this issue is resolved right here. Okay, so what do we do here? This is where we write our queries. So we want to retrieve data from the database. We put it here. We want to insert data into the database. We put it here. All right, so I am going to show you how we can run or write a few queries to do the simple retrieve, insert, update, and delete. All right, so let's begin by writing an insert. If we want to insert data, we use the annotation @insert. All right, and we say, okay, when we are inserting data into the database, what if there is a conflict? Conflict in the sense that that data already exists. We need to provide a mechanism for resolving such a conflict. And so inside the parentheses for @insert, we have on conflict. On conflict, then we provide a way, a strategy for resolving this conflict. So I'm going to say on conflict strategy dot replace. So you can see there is a lot. Okay, the first one says replace. So if we already have the object in the database and we are about to insert another one that is exactly the same as what we already have in the database, then we're just going to replace it. The second one says that we stop. The third one says that it's going to fail. It's going to throw a fail error. The next one is going to ignore it, that it's not going to do it at all. And then the next one is going to roll back the action. All right, so I'm just going to replace it. If the data already exists and it's the same thing, I'm just going to replace it. Okay, then I have an abstract. Fun. Let me introduce suspend fun. All right, this suspend here is a keyword that effectively informs, let me see, no, what should be today? Control, no documentation fun, all right. Suspend allows us to work, to perform this particular operation on a different thread, not on the main thread. All right, so I'm going to define my function, which I call insert, and it's going to take an entity, and that entity is going to be category. And I'm going to return the ID of the objects that I just inserted into the database, which is a long. So it's that simple. We have created a function to insert categories into the database. What about if we want to insert a lot of items at the same time? We can do the same on conflicts. We use, and I say insert all, then I'm going to provide a list of entities or a collection of entities. I'm using collection because I don't know whether it's going to be an array or it's going to be a list. All of them come from this parent class called collection. So, and this is it. So we can supply a list or an array of category objects to this function, and it's going to insert all into the database for us. And Room is going to handle that on its own. We don't have to say run a loop or see how to insert it one after the other. Room is just going to take it and do it for us. All right, but what if you want to make some change? You want to update the state of a particular object in the database. We have this annotation to do that. So on conflict strategy, I'm still going to use replace. And we have suspend fun. I also want this not to run on the main thread, so my application can keep running while I am doing this. All right, that is all. What if we want to delete? So we call delete, and delete we don't even have to provide. We want to take something, so away, we want to remove it. So we don't even need to provide, there shouldn't be any conflicts with this kind of command. I also want to delete the objects asynchronously. So I use the suspend fun, and I'm just going to provide the entity that I want to delete, and go return an int or a long. That is going to be the ID of the object that has been deleted. All right, now that we have done all that we've seen here so far is to put data in, to update data, to delete data. But what if we want to retrieve data? What do we do? So to retrieve data, we use something we call query. All right, and in this parenthesis, see this value here. This is where we write our query. So say we want to select, let me write there. Yep, let me run this asynchronously. We want to get category with a particular name, with a specific name. So we provide a name and we want to retrieve the category that has that name. It is possible that the category may not exist, and that is going to return a null response. And so in here, we need to write our query. So we're going to retrieve data, we call select, star means all, from our categories table where name equals, and we need to provide this name, excuse me. We need to provide this variable that we are passing after the colon. Okay, so this is it. Now, there is an issue. We see these two in red. That is because this entity, this relation or table does not exist. Room is not aware of this, and that is true. That is true because we have not created it yet. Currently, if we go to our category, if we go to our category entity, we see it's just a data class. There is nothing that makes this a database table or that maps this into a database table. That is a better way to put it. So we need to do that to convert, to ensure that this data class is it's a relation or can be mapped to a database table. We have to annotate this as well. So we annotate it with an entity. And if you annotate an entity, you need to provide a table name. What is going to be the name of this table? And I said we make this plural, small letters. And we can index this table. So I'm just going to go ahead and I'm going to index this, and I'll be indexing the name field. We import, yeah. I'm going to index the name field, and I'm going to say that the name field should be unique. All right, so let's come into our data class then. Category, I want to make my ID the primary key. So I'm just going to put an annotation primary key in front, and I'm going to say auto-generate equals true. And then I'm going to name this column as name. Okay, so I'm going to give it the, my ID is, the column name is going to be ID. And I'm going to do the same thing for this. The name is going to be name. All right, so now we have just made this category data class into an entity. And so we go back to our category DAO and you see everything is resolved because now it sees these categories here. And then it sees this where this is a column name, okay, in the database, and it sees it here. So we can supply a string of a name of a category, and it's going to select every instance, or it's going to select all the columns from categories that match. Excuse me, it's going to select every column that matches an entity with a name that we supply. Okay, we can write a few other ones. What if we want to select a list of items, for instance? And so select star from categories where, oh, we are selecting a list. So we can provide a limit that when we want to select all categories, we want to select only, we want to limit it to 15 categories. And we want to return our data as a flow. And a flow of a list of categories. Yes. We can remove this and it's going to retrieve all categories. If there are 100 of them, it's going to retrieve all 100. But we are saying that if we just want to limit it to 15 at a time. So it's just going to retrieve 15 for us. Last, I would want to retrieve by ID. So select star from categories web ID equals category ID. So I want this to be direct. I don't want to use category with ID. Of course, if the ID does not exist, it's going to return a null. Okay, so this is our category. DAO, it's the one that is going to communicate with our database here, and it's going to be doing the insertion and retrieval for us. Okay, now that we have done that, how do we get this data into our application? That is when we use what we call the repository. So we are going to create a new package. And we're going to call this repository. And then we create a class in there, we call it category repository. All right, for now, I'm just going to use a class, but there is a better way to do this. We are not supposed to expose this at all. We just need to expose functions of the actions that this category repository does. And so the best way actually to do this is to create an interface and then implement the interface. But I will do that in a different video. So we need a category repository, and this category repository is going to take category DAO. All right, so this repository is going to communicate with the DAO, and the DAO is going to communicate with the database. And then this repository then is going to communicate with the application. And it's going to communicate with the application through the ViewModel before the ViewModel updates the UI. There is even an extra layer of using use cases, but that we may do later on, or we may not touch on at all. I may do a video of how to use use cases and demonstrate that later on for you as well. Okay, so quickly, we want to get categories, all categories, right? So we create a function for categories, and it's supposed to return a flow of a list of categories. Technically, this function is the same thing that we define here. So it's going to return a list of categories, import. And this function is going to be equal to category DAO dot categories. And that is it. Our next one we want to get our category with ID, and we know that it can return a null. So category DAO that gets category with ID, and we are just going to supply this category ID in there. Awesome. So the next thing is to add a category. All right. So I want to add a category, and I'm going to add it using a suspend function. And it should return a long. So we're going to add a category to the database if it does not exist. And then we're going to return the ID of the newly added or created category. That is what is happening here. Okay, so what do? We are going to return, we are returning a value. So we're going to return when we create a val local. This value could be anything, and that is going to be, we call category DAO dot get category with name, for instance. All right, so we are adding a category. We pass a category object. Now we will first of all want to check from the database if the category exists. If it exists, we may or we may not. This is not as important because we already, in here, we already have inserts. Where's our insert? We'll have an insert, and the strategy for resolving the conflict is to replace it. So we easily could just add it. But I am just doing this to demo that if your strategy is not insert, first of all, you can actually find out if it already exists. And I'm using name, category name, because over here, I made I make sure that the name is unique. The index for the name is unique. We could use ID to be safer. So that is one. But if you use an ID, you know that when you're creating a category, since the ID of the category is auto-generated when you're creating it, it's not yet generated yet. So you may have some issues with that. All right, so what if local here is null? That is when we retrieve this, it returns a null value. If local is null, then we call category DAO. It means if it is null, it means the category does not exist. So we insert the category. Else, we just return the ID. Remember, add category is returning a long. So if it already exists, we just return the ID, which is going to be long. If it does not exist, then we insert it. When we insert it, insert returns an ID, which is a long. So it's going to return the long anyway. And that is why we're using the return here. So either way, we are going to return an ID, and that ID is what this add category is going to be returning. All right, so we are almost done with our first database entity, but we are not quite there yet. Do you remember that we created a graph class object? Did we? No. Okay, we did not. Awesome. This whole time I thought we had. All right. So I'm going to create an object, and I'm going to name it graph. All right. This object is going to be a singleton, a simple singleton class that works as a dependency graph. Okay, so for a real app, please use something like coin, gap, or hilt. All right, but we are going to create a very simple graph, and you can use this in your project, of course. All right, what this object is going to do is that it's going to act as our dependency injection setup. It's going to be making variables and other general objects readily available that we can pass in, so we don't have to create instances and have our code tightly coupled. It's a very good way of decoupling stuff. I will be providing a link to Bob C. Martin's book on software architecture, or clean code of showing how this dependency injection framework can be super, super useful. All right, so to do that, we have created our database, all right, but it has not been instantiated yet. We are going to do the instantiation here. So let init var database. Oh, our database is called mobile. Yeah. And let's call we create a function called provide that contains, context. And so here, our database, we are going to instantiate our database room.database builder. That takes the context. And our database class, mobile computing database class.java. And then the name of the database. So here we create the name of the database. I'm going to call it data.db. It can be any name, but please ensure you have the .db. All right, And we are going to add a fallback. Okay, what happens when we are doing a migration? When we are migrating from one version of the database to another version? I'm going to say it should be destructive. But please do not use this one in a production app, okay? This is just for demo purposes. Now this, if we hover on this fallback to destructive migration, it allows room to destructively recreate the database tables if migrations that would migrate old database schemas to the latest one are not found. So this is technically just going to delete the previous database and create a new one if it doesn't find the schemas that are supposed to help it convert or move from one database version to another. So you make changes to your database and you want to upgrade. You don't want to delete the data that already is in the application that users already have, but this function is going to do that. It's going to delete everything and recreate. So please do not use this in production apps. That's why I left this comment here. But we just want to test stuff and build things quickly. So that is why I am doing this. All right. Last, we are going to make a category repository, which we created over here. We are going to make it available. So category repository. And we are going to make it available through lazily available. And if we look at our category repository, it requires a DAO, right? Where do we pass this DAO? We are passing it here inside this graph. So category DAO equals, and this category DAO is available in the database. So if we open the database, we see it right here. So we are going to call our database, and we are saying category DAOs. So now we just passed our category DAO to the repository in here. And so now we can use this category repository and make calls to these functions that we define here. And these functions actually use the category DAO that we injected. And it uses that to communicate with the database, retrieves data or inserts data, gets stuff for us. And those things, the category repository is going to pass on to whoever is going to use it. All right. So now that we have done this, we will need to try it out. Where do we try it out? Let us see. Okay. Let's go into our home view model. Any questions so far, please? If I do not see your question, please just unmute your mic and ask. Okay. So let's go into our home view model. Okay, so previously in our home view model, when we begin our application in the init, in the initializer, we generate a list of categories and we just add it to our view model. We inject it into the view model, into the states, and it becomes available. Okay, now we want to change that. We want to put this into the database and then retrieve from the database. All right. So to do that, we create a private method to load the categories from database, for instance. Okay, the name doesn't make sense, but to do that, since we can load this from a JSON file or something, but I'm just going to put it in here. And so what we're actually going to, excuse me. Yeah. Okay, so I'm going to create a mutable list, technically move the whole thing. A mutable list of categories. And since our category is if we go to category, where are you? Yeah, our ID is auto-generated. We don't need to provide an ID. All right, so I remove the ID and then I use a name parameter. You can still see when you hover over a category, you can see it requires an ID and a name. So if I do not provide a named parameter, I'm going to be, I'm not supposed to provide an ID. Hold on. Yeah. All right, so I had to initialize the ID value to 0, but this 0 is not going to be used because the database is going to generate an ID for me. All right, so I'm going to change all this. Okay. All right, so now that I have a list of categories, what we're going to do is that we are going to be running in a coroutine scope, which the ViewModel already provides us with. And we're going to say we're going to use launch, which we have used before. And we are going to say, we are going to loop over this, and we're going to say list dot for each category in this list, we are going to call our category repository. And we are going to say add, just a moment. We haven't added category repository yet. All right, so we need to pass the category repository. Private val category repository. And we are going to instantiate that, the graph.category repository. All right. So we are going to pass the category repository we have defined inside a graph to the ViewModel. Now we can use it. So category repository dot add category, and then we're just going to put this category in there. All right. So we are going to be calling this function inside our initialization function. So we can remove all this. And of course, since we have removed the category, we're going to have an issue here. And so what we're going to do is that we can call our category repository. Now dot get categories and then loop on that. And then this is actually going to be a list. Hold on. This is, hold on, this is returning a flow, and the flow is going to be a list. So this is going to be a list. So we say list dot is not empty. Yep, okay, yeah. So our list is a list of categories because this is the flow. And our selected value, that value is not equal to now, then list of 0. All right. Yep, so this is it. We are technically retrieving the categories from the database through the repository, and we are setting the values to the view state again. So all that we are left to do is to call this load categories from DB function here. And so while exactly it is inserting first before loading, but it's going to put this in the database, of course, and then it's going to retrieve it in here for us to use. So this time around, we are not hard coding it, or we are not inserting it directly, it's going into the database. Okay, and since add category in our repository, if we run the application again and it tries to add, it's going to run this function. And since it's already exists, it's not going to insert it again, it's just going to return the ID for us. Okay, this is it. We would be running this and see. But there is one more thing we need to do before we run. Our graph is not known to our application. Oh, I don't think our graph. Yeah, our graph is not known to application. So we need to make our graph known to the whole application. And so we're going to create something we call mobile computing application. All right. Now this is going to extend the application class. The application class is the biggest class. It's what holds the whole Android app. Okay. It is like the parent of everything. So anything you run is running, although you don't even declare it, it is injected in there by Android for you. So we are going to create, we are going to extend that application class. And we're going to say on create of the application class, we are going to extend, we are overriding the on create function in this application class. So this is the application class definition. And as you can see the description here, it is the base class, the base class for maintaining the global application state. All right, so this application class here controls the entire state of any Android app that you see running. And so when we extend this on create of this application class, we are going to provide the application context in which the application context, we're going to provide that to our graph, our dependency injection framework. So this here refers to the application class context. This context is going to be available to every screen, no matter where within the application. So we are providing this context. That means that we are technically making a graph, this graph accessible because it has the context of the whole application, not on each screen. Each activity has its own context. So for instance, this main activity has its own context, but the application context is going to be available here. if we create another activity called, say, profile activity, the main activity context will not exist in the profile activity. The profile activity will have its own context. However, the application context will exist both in this one and in the profile activity. And so because we want our dependency ingestion framework to be accessible everywhere, we put it in the application class. And so when we give the application context to the graph, it means that it is going to be used, it can be used anywhere on any screen. Okay, now let us run this and see if we are going to fail. Okay, so we have an issue here. And it says that in our category DAO line 47, there is an error. I'm not sure how to handle delete meta return type. Currently, the supported return types are void, int, or int. So we come back to the category return, the delete, we used log. So we can say, okay, let's not return anything. And we can leave it like this, or we can return an int. But if we delete, maybe we want to return the ID because we want to restore. So we can leave it as int and then rerun again. Okay, hold on. Payments category. What is that? Unresolved reference. Ah, I changed the name. Payments, where you are. I changed to payment ID, okay. Payment category ID. We'll resolve this a bit later. And this is also a long. I would comment this up and we'll resolve this as well when we work with a payment repository. And I think this should be it. Geez. Lots of breaking changes, but all this is going to go away. We are going to be inserting data from, we're going to be inserting the data ourselves anyway. Okay. All right. Now something happened. It crashed. Awesome. Let's see what our issue is. Latent property database has not been initialized. Interesting. Reinitializing you here. Why isn't this initialized? Okay. Let me clean my project first and rebuild. Okay, let's run this again. All right. This is interesting. Okay, so let's try this again. All right, what does it say? Same error. Okay, right. So now I know where this is happening. It is happening because when we created our application class, we didn't add it to the manifest. Remember, I said this in the previous video that whenever you create an activity, you need to come ensure that it is here. And well, it so happened that it caught me. So here, we need to add a reference to the application class that was created. All right, so now that it is in here, we can go ahead and rerun. And because this hadn't been added to the Android manifest, this wasn't being executed. So now it's running again, and then we click login. Voila, awesome. Now the login comes up and we can scroll, we can select, but you notice that nothing is changing here. That is because we haven't worked on the payment side yet. But I'm gonna go ahead and I'm gonna clear, that should be in the home. Yeah, home here. And I'm gonna hide details for the payment. Okay, so I'm gonna hide this. I'm just going to show the tabs at the top and demonstrate that this has been read from the database. Okay, so we click this and yep. So now we are reading this from the database. Awesome. So this issue is fixed. In the next video, I'm going to show how we can add payments. Of course, I've been making a change to this particular UI. I'll take off the data and just and then include load the categories here and display in here. And so we'll see how we can add a payment there and see it reflect here, and how we can click on these to see a change. So thank you once again. Always remember that the issue had been with the manifest file. So we had to come into the Android manifest and include application class, and that was it.